I'm going to do a brief example on the speed of light. So first off, the speed of light in a vacuum or empty space is very fast. We have a symbol for the speed of light. We call it c, partly because the speed of light is a constant in all reference frames. And the speed of light rounded is 3 times 10 to the 8th meters per second, which is incredibly fast. I believe it's about 8 laps around the Earth in a second for a light beam. One example we're going to do is we're going to use our equation velocity is distance over time equation. The velocity being the speed of light. So if somebody tells you we have light, you know its velocity if it's in outer space or in empty air. And so we have that number. So let's say I look up the distance today from Earth to Jupiter. So let's say you sent a space mission to Jupiter, and they're circling Jupiter now, and you want to contact them. How long will it take a signal, like a radio wave, which goes the same speed as light, how long will it take to get there? So if you have your astronauts out there, like, you want to tell them, hey, change course, how long does it take to get out there? So the distance from Earth to Jupiter today, I looked it up, is 489 million miles. Okay. Now we need to make that into meters so we can put it into our equation because our speed of light is in meters per second. So 489 million would be 489 times 10 to the 6th, and that's miles. So a million is 10 to the 6th. And then there are 1609 meters in 1 mile. And so if you calculate that out in your calculator, you get approximately 7.87 times 10 to the 11th meters. Okay, so that's how far Jupiter is away today as I'm making this video. Now, we're going to use our velocity equation to find how much time it takes that a light or radio signal to get from Earth to Jupiter. So I'm going to multiply both sides by time. So VT is equal to distance. And again, I'm going to solve for time, so I'm going to divide by V on both sides. So V is distance over time. So our distance is 7.87 times 10 to the 11th meters. And our time, oh, wait, we don't want that. Scratch that. We want time, okay? So time, is distance over velocity. All right, so our distance is 7.87 times 10 to the 11th meters. And our velocity is the speed of light, which is 3 times 10 to the 8th meters per second. When you divide those out, the meters will cancel, and you're going to have 1 over seconds, which is seconds. I do suggest you actually try this out in the calculator with a scientific notation just to make sure you get it right. But when I do this, I get 2,623, and the units are seconds. If I divide that by 60 to get minutes, I get 43.7 minutes. So if I want to send a radio signal to my astronauts on Jupiter, it's going to take that radio signal almost 44 minutes to get to Jupiter. We're going to give you other problems while you'll be using this equation. It'll just be different things, like they'll give you maybe a distance and a time and ask for velocity, or so on. But that's the general equation for finding the relationship between distance, velocity, and time. And given that we know the velocity of light is 3 times 10 to the 8th. I hope that was helpful, and thank you very much.